Find the CY or find the transfer function for the signal flow graph by using Mason gain formula. Previous class I has discussed about the touching loop and forward path. Today I will discuss about the non-touching loops and touching loops and forward path. Here the forward path is 1. The number of forward path is 1 to 6. It is a one forward path. Therefore, the forward path is 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6 input or output. See, it is a forward path. The forward path gain is the forward path gain P1 is equal to G1, G2, G3, G4. And the G1, G2, G3, G4. Then there will be G1, G2, G3, G4. Therefore the forward path gain G1 into G2 to G3 to G4 is a forward path gain. The next loops, and the number there are the 4 individual loop. The 4 individual loops. Loop 1. Here the loop, so one loop, it's called a self loop. Therefore loop gain L1 is equal to -1. Loop 2, here the 4, 5 to 4 again 5. Loop 4, 5. The G4 and -1 for loop gain L2 is equal to minus G4. Loop 3 to 4, 4 to 5. This 3, 4, 5. -1. Here the G3, here G4. Therefore loop gain L3 is equal to minus G3, G4. The loop 4 is 2 to 5. 2, 3, 4, 5. 3, 4, 5 is connected to node 2, and the feedback path is -1. G2, G3, G4. Therefore, the loop gain L4 is equal to minus G2, G3, G4, G2, G3, G4. For there are four loops. The loops are touching loops. We'll see the non-touching loops. Here, the non-touching loops. And the non-touching loops here, the node 2 here, the loops is a non-touching loops. Here also the node 4 to 5, this node is a non-touching loops. These loops are not touching to the another loops. This touching only one terminal, another terminal is not touching the another terminal is not touching this loop. It's called the non-touching loops. Here it is a non-touching loops. The rest loops are touching. Here the number of two non-touching loops. The number of two non-touching loops, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. Here the 4 to 5 is G4. The two non-touching loops, here the one non-touching loops, here the one non-touching loops. The non-touching loops L1 is equal to minus 1, and the non-touching loops 2 is equal to minus G4. Therefore, the gain product of two non-touching loop, the gain product the non-touching loop L12 is equal to G4. According to the Mason gain formula, the sum of gain product all possible of combination of two non-touching loop. It is the second combination of two non-touching loops. Here it is the first combination of two non-touching loops. It is the second combination of two non-touching loops. Here it is a loops, it is loops, it's a loops, and these loops there are not touching, and these loops from 3 node to 5, these loops, and here these loops are not touching. Here the two not touching loops, and these loops from node to 5, its loops and self loops is touching to each other. Therefore, here the two non-touching loops. Loop, therefore the loop gain product is L13 is equal to L1 into L3 from G3 to G4, G3 into G4. The L here the L1 is equal to minus 1 and the L3 is equal to minus G3 G4. Here the L3 is equal to minus G3 G4. Here the L1 is equal to minus 1. The gain product of two non-touching loop is equal to its multiply with G3 into G4 with minus 1. Therefore, the result is L13 is equal to G3 into G4. So the number loops 1 is loops 2, its loops 1 is loops 3. The loop gain product is equal to L13 is equal to G3 into G4. It is the Mason gain formula we discussed in the previous class. So here the del is equal to the 1 minus within bracket sum of individual loop gain. Therefore del is equal to 1 minus within bracket sum of all individual loop gain. The first loop gain is minus 1, second minus G4, third G4 into G3, and fourth minus G2, G3, G4. Here I put the value of individual loop gain. Here the loop gain is 4 plus the sum of gain product of all possible combination of two non-touching loops. Here the two non-touching loop combination is G4 plus G3 into G4. Here the number of forward path del 1 is equal to 1 minus 0 is equal to 1. Therefore, gain formula Ts is equal to 1 by del into P1 del 1. Therefore, the transfer function Ts is equal to, here I will put the value of forward path, or here I will put the value of del. The del value is this is the del value. Here the forward path is forward path gain G1, G2, G3, G4. I'll put the value of del 1 plus 1 plus G4 plus G4 into G3 plus G2, G3, G4 plus G4 plus G3 to G4. The second line is G1, G2, G3, G4 by 2 plus G4 plus G4, G3 plus G2, G3, G4 plus G4 plus G3, G4. It is the transfer function of signal flow graph.